Hello everyone. Welcome to the solution of LeetCode problem 2390 named removing a star from a string. In this problem, we are given a string S in which this S contains the star sign. In one operation, we have to choose a star in the string S and remove the closest non-star character to its left side, as well as we have to remove the star itself. Now, after that, we have to return the string after all the star has been removed. Now, we have to note that the input will be guaranteed such that the operation is always possible, and it can be shown that the resulting string will always be unique. Now, if we see the first example, the input is this, which is leet after this 2 star, then COD after this 1 star, and finally, this is E. So if we perform the operations, for these 2 stars, we have to remove the left 2 non-star elements. So here we have to remove E and T. So for this star, we have to remove the element D, which is non-star. So finally, the string will become LECO and E, which is LECO and E. Now, in the second example, the input string is ERASE. After that, there will be 5 star. So for this 5 star, we have to remove the left non-star element. So as there are 5 stars, we have to remove 5 elements. So the entire string will be removed. So here we have to output the empty string. I hope you understood the problem statement as well as the examples. Now the constraint are the string length can be in between 1 to 10 to the power 5. And each of the character consists of lowercase English letters and a star. And the operation above can be performed on the string S. I hope you understood the problem statement. Now let's move on to the algorithm. Now, to solve this problem, we will use the stacked data structure. So here the algorithm is pretty simple. We have to take one stack here. So we know that stack operates in last in first out manner. That means the element which enters in the stack at the last should be removed at the first. So here we have to run a loop from left to right. And for each of the non-star character, we have to insert them into the stack. Suppose first our character is L, so it is non-star. That means we have to insert L here. After that, our element will be E. So we have to insert the element E here. After that, the element is another E. So we have to insert another E here. After that, the element is T. So we have to insert T here. Now we have found 1 star. So according to the problem definition, if we found 1 star, we have to remove the recent non-star element from the left. So we have to remove the element T. So here we are removing the element T. That means we have to pop the element T from the stack. Now, our current pointer is pointing to the next star, which is this. So we have to again remove the top element from the stack. So here we have to remove element another E from the stack. So now our stack only has 2 elements, which is L and E. Now again for these 3 elements C, O and D, we have to insert them in the stack, which is C, O and D. Now we have found another star here. So we have to remove the top element from the stack. We have to remove D. Now, finally, we are at this last element, which is E. So we have to again insert E here. Now, the string is LECOE, which is from top to bottom. That means here we have to perform another operations. We have to pop each of the element from the stack. So here we know that we have to pop the element from the stack from the top. So here we have to first remove the element E. After that, we have to remove the element O. After that, we have to remove the element C. After that, we have to remove the element E again. Finally, we have to remove the element L. This sequence is exactly opposite to this sequence. That means the bottom element is L, which is the last element of this string L. So now this is not the desired output. So we have to reverse this string. So after reversing this string will become L E C O E, which is the respective output. Now we have seen that if we use the stack data structure, we have to perform additional operation, which is we have to remove all of the elements from the stack and consider it as a string, and finally we have to reverse the string. So removing all of the elements from the stack will use big O of n time complexity, and reversing will also take another time complexity. So it is one kind of expensive operations. So this problem can be solved by using simple string data structure. Yes, it can be solved using stack, and it is one kind of algorithm, but for the sake of simplicity and to reduce the time complexity, we are using the simple string algorithm. So here the algorithm is pretty simple. At first, we have to remove all of this mechanism here. Now the algorithm is pretty simple. We have to take a string. The name of this string will be answered. Initially, it will be empty. Now we have to run a loop from left to right. Now, if we found any of the non-star element, we have to simply append those elements into the given string. So here, the string will be L, E, E, T after the 4 iteration. That means these 4 non-star character will be added here. Now, for this 2 star, we have to remove the left 2 element. So here we have to remove the element E and T. Now again, for these 3 elements C, O, D, we have to append it here, which is C, O, and D. Now again, we have found 1 star. So here we have to remove 1 left element. So we are removing D. Now again, we have found D. So we have to insert the element E. Now finally, we have noticing that the remaining element will be L, E, C, O, and E. So we have seen that this algorithm is much more concise than the previous stack algorithm. Anyways, I am explaining 2 of the algorithms here to solve this problem, but the solution code will be implemented using this easy approach. I hope you understood both of the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named remove stars, which is a parameter string. Now we are taking an answer variable, which is a string type. Now we are iterating each of the character of the string. And we are checking if our current string is not empty and our current string is a star. If it is, then we have to remove the left element from the output string answer. So we are using pop back here. Otherwise, we have to simply insert the current element into the answer. Finally, we have to return the answer. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n because we have to iterate each of the character in the string, where n is the size of the string. And the space complexity is also big O of n because we are taking one additional memory to store the answer. And in the worst case, the size of the additional memory can be equal to the size of the input string. So we can say that the space complexity is also big O of n. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.